So I've been busy with some upstreaming and some other stuff, but I think it's about time we look at the speakers again. So last time I spent a bunch of time on a Python Jupyter notebook trying to figure out the algorithm for predicting the speaker temperatures based on the VI sense data from the amps, and that all seems to work pretty well. So the next thing is actually getting a daemon that can run that simulation and protect the speakers. And so because this is a safety critical piece of software, it makes sense to write it in Rust because we don't want, random memory corruption to end up letting you blow up your speakers. Though the good news, of course, is that this is a safety fallback. It's not like this daemon isn't actually sending audio to the speakers, so it would be difficult for a problem in this daemon itself to like immediately blow up your speakers, but it would, break the safety. And so ChatMid has already gotten started on this, and there's some demo stuff. So we're going to look at that and see how far we get with it. So the test machine, actually, hold on a second, let me get my little jacket here. It's getting cold. The test machine is going to be a 14-inch M1 Pro MacBook Pro, which is the same one that ChatMid's using. So that's going to be our first target. And so, the plan is to get the simulation into the daemon, make sure that it matches what we expect, figure out how it's going to control the volume, which is how it will basically throttle the audio so it doesn't blow the speakers if it gets too hot. And then there are a bunch of subtleties around safety that we need to work out. And then most importantly, there's a bunch of subtleties around how it's going to interlock with the kernel. We have to deal with sample rate changes. We don't want to block other things that are sending audio to the kernel. We don't want to have to synchronize in real time the sample rates. There's a bunch of subtleties and things that will probably require kernel patches. So, but first, let's just get the thing running and doing its job, and hopefully, prove that the speakers don't blow up. And then we'll see about all the interlocks. Let me get my editor here. And I'll switch the screen in a second. I guess that works. Yeah, it should be fine. All right. Let me check the chat. Hey, Joey's here. Mark inciting. Yeah. I've been spending time upstreaming and fighting with kernel maintainers, though I do have some good news that I'm not going to share right now because it's not done yet. But let's say potential good news. So hopefully, I'm not feeling as annoyed at the insert vague kernel thing here right now as I was last week. Can I use the same safety values on MacBook and MacBook Pro? No, every laptop has the same. It has different speakers, or some of them share some speaker types, but it's not a single set of configurations. But we have all that data from Apple for all the machines except the M1 13-inch Air and Pro, which didn't have this feature in macOS at all. So I am actually going to experimentally derive my own models for those machines, and I actually just got a temperature probe, and it's going to involve sticking the thing in the fridge and then taking a sample, and then sticking it into a warm closet and taking a sample, and then doing some logging and optimizing the fit for the curves and stuff. But that that's going to come later. Sort of my roadmap for this is to first get it all to work properly on this one, on the 14-inch Pro. And then I'm thinking of the M2 Air, because that's the one I blew up, and they want to prove that this will stop it from blowing up. That also means I have to come up with the actual like EQ curves for it, because otherwise that doesn't make any sense. But yeah, I mean, other than those, the two original M1 laptops, we have the numbers from macOS. I guess just in plist. Was it plist files? Yeah, I think it was a plist in macOS. So we can easily get those values for current and new machines. Okay, so thankfully my C cache was up to date, so that kernel build did not take too long. I don't know if I'm actually booted right now into a kernel that has VI-Sense or not. What's the uptime on this? 6 days. No, I think I rebooted that for something. Oh, it's the kernel here. Yeah, this is just the Arch kernel. Okay, so we're going to reboot that. And I need my mini stuff here. And yeah, this has the please put up my speaker stuff. And as usual, I need to use Linux PY. I can't use the hypervisor for this because that will screw up timing and do weird things to the audio. By the way, the actual model is the same for all the machines. Just the constants change. So we don't have to write code for every machine. It's just there has to be a configuration file, which we actually have an example of here with dummy values. And there's actually some more stuff that we have to do here because the volume reduction has to be linked between at least speakers of the same type. So all the woofers have to be linked, and also both tweeters. And there's two reasons for that. One is for the stereo image to not get completely out of whack when you go into thermal limits. And the other one is so that, for example, the woofers are firing in the inverse direction, the two pairs for the left and for the right. So you definitely don't want them to unbalance themselves, which might make for more problems when you're running into temperature limits. So you need speaker groups, basically. So that's another thing that has to happen. You calculate the temperature and the limits and everything individually for every speaker, and then you take the min of the volume of the limited volume for all of them, and you apply that to all of them. So that's more logic that has to happen there. So let's see what we have so far for speaker safety. So this is now booted into the right kernel. Let's see how far I can go without having to touch the kernel. I should be able to implement all the actual limiting without touching the kernel. And then when we start looking into the safety interlocks and the sample rate stuff, that's going to probably require some patches there. So we have Git here. Where is that? Yeah, let's just clone it here. I do have Rust here, of course, because I use it for the kernels. Okay, so it's the CHFS. Okay, that should be what I want for that. Asahi Git speaker safety D. So it's been forever since I've touched Rust. The last thing I wrote was the mini chain loader stuff. This is now user space Rust, which the last thing I wrote for user space Rust was I don't know, like years ago, I think. But yeah, I've been watching some of Lena's stuff, so hopefully some of that stuck. So here's the source. I think it's just cargo build for this stuff. Yeah. So let's open things up and see what we have. Okay, so this is the ELSA stuff, and this is using some ELSA crate. Yeah, some cargo takes care of that. That's right, I'm going to draw the iSense switch. Yeah, the switches, honestly, we might as well just hard code those in the kernel to always on, because you always want them on. Level, LM, yes, that's the actual volume. And then we need a thing so that only this daemon can touch those things after poking an interlock. GRV is what, just the driver name? Like the driver isn't speaker, I guess. Yeah, that looks about right. Okay, so DC. Do we need the resistance for anything? I don't think so. I think that's just, yeah, it's not even here anymore. Yeah, we need the taus and the we're missing something here. The thermal resistance of the magnet. And what was that called? I think there was a name for that I was using in my other experiments. And that was another thing. I haven't looked at the config parsing. I assume there's some nice crates you can use for that. Config parser, yeah. INI style, yeah, I'm fine with that. I wasn't sure what format to use, but I don't really care as long as it works. Though I might change the layout here because we need groups for them. This looks quite reasonable though. I'm wondering if we want to like deduplicate identical speakers, because I think all the woofers are the same and all the tweeters are the same in these machines, but I'm not sure if that actually makes a lot of sense. I called it Tempco. Yeah, that makes sense. Where is types here? Where was I? I know, no, Tempco. No, Tempco is different. Tempco is the resistance temperature coefficient. This is thermal resistance, but I think I had a name for that. Hold on, just look at. Oh, you can't read IPy notebooks. So alpha is the it's calculated from the temperature from the time constant. But where is the RT? RT is what I called it for thermal resistance. Okay, and you called it TR. Yeah. Oh, okay. Yeah, sure. Yeah, TR is fine then. I'm just wondering if we want to deduplicate, we might want to. Though Apple doesn't. So maybe we might even want to make a converter at some point, and then deduplicating doesn't make sense. I guess I might as well not overcomplicate things. So what I can do, though, is steal the values from Apple's stuff, which actually, let me find that. This is in vendor. Vince, even though it's not Vince. Audio DSP, contents, macOS, no, resources, tunings, yes. And what's the AID of this thing again? Also, we probably need some mapping between machine names and speaker configs, because I do expect some deduplication there, but that can just be symlinks. So Asahi proxy client D1 Pro ADT acoustic ID 8. Okay. Yep. So acoustic ID 8. And the safety stuff there is in AU, I think. What was that? Is it IRs? No. Wait, where was that? I can't find it. That's all the microphone stuff. Has to be an AU. I'm confused. I could have sworn it's here. What? Oh, in tunings. Okay. It's under. Oh, it's not under audio DSP. Those are the actual. Yeah. Okay. I think it's just under DSP strips. Yes, this one. The SPP thing, speaker protection. So I'm just going to open that in Kate. I could just make a converter, to be honest, but I guess let's just do the obvious thing. So I think all the woofers are the same. The only thing we really care about is the T-set VC and the yes, that's the same for that one, and same for the woofer right, and same for the woofer right. Tau TVC, I think, is also the same for everything. Yeah, I'm pretty sure these are all the same. And T magnet T19245, 45, and yeah. So the settings are the same for all the woofers and all the tweeters. I'm just going to write a converter because we're going to need that anyway. It'll be a lot less error prone than trying to do it by hand, and it's trivial enough in Python. Speakers, import plist, Python, call it with that. So what you want to do here is actually the I don't know if those gain attack time and release times really matter. Actually, let me do a little recon on that. I'm curious as to whether those ever change. Oh, only 3 AIDs have. Okay, yeah. I need to look at what's on the. Well, this was before M2. I think I took these. No, this might have M2. I'm not sure. Let me look at the device trees real quick. Device trees 2.4 definitely has those. Okay, so yeah, the M2 Air is 13. The 314s are 8. The 316s are 9. And the others don't have safety models, the iMac and all that. I don't know if we want a safety model for the iMac. The iMac, I think we still don't support the AMP chips yet anyway, so that's probably the last one to get support. The Mini and the Studio, we don't really care about the tinny internal speaker. I don't think that needs a safety model. But yes, let's see. These all look like the same settings for everything. So I think we can just hard code these in the daemon for now, or have them as global settings or something. Maybe it could be, yeah, it should be in a global setting, I think. I guess we might as well imitate what Apple's doing. Yeah, I mean, EQing it is fine, but I mean, you can probably blow it up if you drive it too hard. But we should just have a known safe volume, output level, and that's it. And the main problem is the tweeters, right? When we have a split between woofers and tweeters for machines that are 2-way or 3-way, because then it's program dependent, right? Then you have a crossover, which means that you want to drive the tweeter a lot harder, relative to the absolute max, because most material doesn't have a lot of high end. But then it means that if you do have an artificial signal with a ton of high end, you're going to blow up the tweeters. So this stuff is really most important in machines with more than one speaker per channel, which doesn't include the original M1 Air, even though I would still want to do it for that one. But I think does include the original M1 Pro, so that'll be interesting to add. It has two, I think. So it has 4 drivers, but I assume it's a tweeter and a woofer for each side. Anyway. When I really pushed my end to air, I think I might have damaged the woofers, maybe, but the ones that really blew up are the tweeters. So not all the 13-inch. The original M1 Air is one way, I think. The 13-inch Pro should be 2-way. So yeah, let's just let's just copy what Apple does, because I mean this is just some pretty obvious data. Yep, job not done until I can play I Want the Loudness at max volume for like half an hour and everything, and measure the speakers before and after that, and they have the same response. Import sys, this is pretty easy. Equals list load. I think, is this the same as JSON? I think it is. I don't know. Let's see if I'm remember my Python. Where am I? So I'll just take this on AAD8 for now. Oof, that is not. Oh, open. I do remember my Python. Expected byte stir found. That means binary, I guess. Yeah, that works. Yep. Okay, we're good. Version 9. That's interesting. So let's just map things. How do I want to map these things? Let's just make a little list of apps. T ambient would be thermal ambient temp. I don't know if we care about the gain attack times and the gain release times. I don't even know if we want to set them to that. Honestly, that gain attack time looks way too long. I would rather just hardcode that, to be honest, than the daemon, because I want the attack time for gain reduction to be way faster than that, because I know you can bring up the coils in those tweeters to a ridiculous temperature in like a second if you are really pushing them. So yeah, I don't even sure care about that. Ambient temperature might make sense in terms to have variable in terms of the maximum expected like case temperature on the speaker that you're relative to, which that's another cute thing we could do. We could actually use case temperature, and that would let you drive the speakers a bit harder if the ambient temperature is lower. But for that, the hardware monitoring driver needs to work. That's a different story. And then there's a safety lim time min and a safety lim offset, and I wonder if this is like for initialization, or is that the temp? That's the thing, is I don't know how Apple's temperature limiting model behaves. I know we have the temperature limit, and so I assume we definitely don't want that to ever go above that. But I don't know how their actual temperature like governor works, and I don't know what this means, like the safety lim. Oh yeah, I mean, instant attack is a bad idea, but I mean, I was thinking of like an attack time of like 100 milliseconds, which is definitely fast enough, to protect your speakers. I interpret it as for every degree between safety limit and temperature limit dropped by XDV. Yeah, that makes sense. But then I don't know what the time min means. And then there's an offset there, which also I don't understand. Also, the reduction value can be calculated from the power, right? That's something that Daemon's going to do. It just uses the temperature, the ambient temperature, and the thermal resistance values to calculate the maximum sustained output power. And then, the delta between that and the actual maximum output power for whatever is configured in the amp is the maximum gain reduction. And so, you can always fall back to that if you need them to be safe. Can they put in connectors into the speaker? Yes, they put the speaker resistance, and that's in the device tree. But we only need that to measure temperature for calibration purposes. I don't think we need that for the actual safety model, so the Daemon doesn't have to care about that. I will when I measure the original M1 max to derive the model, though. But I also need to measure the thermal coefficient, which is more important, actually, so I'm going to calibrate it myself anyway. Also, I don't think we need look ahead. There's not much point in that. Well, we can't anyway, because this is purely reactive. The displacement we don't care about. We don't enable displacement as far as I know. Enable displacement control false. So I'm going to put an assert here. So yeah, safety lim offset is the one thing that I'm not sure about. Unless that's in dB? Or is it like from 100 to 115 that it actually does the gain reduction? Or to like 85 to 100? It's really not clear what these things, how they are actually interpreted by the macOS safety stuff. And of course I could, try to measure it, but I'm going to call that tsafe max, and then we'll do what James said. And I don't know what to do with the rest of the parameters. I don't get what the time in there and the offset stuff has to do with any of this. So unless safety lim offset is like applied to the maximum temperature limit here, so like there's an extra offset of 15 on that, which would mean 125 is the actual max reduction temperature. Maybe that's what's going on, but I'm not sure. But there's a hard temp limit headroom, which makes more sense as that getting subtracted from here. But then that could also be added, though, if this is already has. Yeah, it's kind of hard to. I mean, 10 degrees isn't going to like make the difference between melting the speaker or not, but yeah. But I'm tempted to say that we should make the actual max reduction at temperature limit minus hard temp limit headroom. We can probably just store those. And then just reduce from here. I don't know what the offset is. Unless that is like the dB reduction. But I would rather calculate that. And I don't know what the time is about. The thing is, time min makes me think that this is some kind of like extra safety mode or something like that. But I'm not sure. Oh, hey, Dreamer's here. Could also be that this, minus 10 is actually the like gain reduction range. So up to 130, you're allowed to crank the speakers up. Yeah, it could be that they enable this codec safety mode or something like that. I don't know. It's we'd have to really look into what macOS is doing, and I'm not sure it really matters because as long as we have a temperature model, as long as we keep the speakers within the absolute maximum temperature, who cares how we implement the actual governor? So anyway, I think we can get away with just having those values here in this file. For print. And it's just equal syntax, I think. Yeah. And then we have to get the channels. Just in case the order here is messed up, let's do this as indexing like that. Equals PL channel specific params. And then we have the groups. Oh, sorry, I got a package. I'll be right back. I came back. Anyway, speaker name. We also need the group. And that's just an integer. We can use the same format. And then in OL thermal, that's a dict. And items. So I don't know if we care about the shunt stuff now. We don't care about resistance measuring anyway. I don't know what REB is or the RAM powder stuff. We care about these. Those are the thermal resistances. So what do we have here? RT, TR coil, and TR magnet. Okay, so TR coil is and we got on tau coil. So obviously the names will have to be renamed to the ASA names later, but that's fine. Global maps. This is in therm maps. Therm pk. Okay. And then those are important to get right. What is the RAM factor? Is that one of the other things they had, or do we just make that up? But anyway. Plist integer object cannot be what? Okay, that's reasonable. I think we can get away with less float precision there. What was it, Rython? Yeah. Yeah. Tau TMG. Okay. And we went an extra print here. Okay, so there's our definitions. Okay, I think that's reasonable. Sri Asahi git speaker safety. Just throw it on there as. I'm just going to append it and then fix it. For 2, right woofer 1, right woofer 2. Left tweeter, right tweeter. And then those, actually, was I always first? I think I was first, right? I mean, you probably want to put them in that order because it's a bit easier to understand. Yeah, and let's sort them like that then. It's a bit easier. So left woofer 1 is 4 and 5. Right woofer 1 is 7, 6, and 7. Left woofer 2 is 8 and 9. Right woofer 2 is 10 and 11. Left tweeter is 0 and 1. And right tweeter is 2 and 3. And those channels, are these actually the right channels we had? Didn't we have a different order in the end for this machine? Or am I confusing myself? Because I first did the woofer, and that was channel 0 and 1, I think. Our order is woofer 1 LR, tweeter LR, woofer 2 LR. So I think that is not right. It should be 0, 1, 2, 3, 4, 5, 6, 7. And then 8, 9, 10, 11. I think that's the right order. And then we might as well sort them in that order too to make it a bit easier. So this is still going to need some manual editing to make it look nice, but at least the values are coming from the macOS thing. And we can drop that. Okay. So there's a config file with reasonable numbers in it. Do we want to channel count, or we can calculate that? We can just have the channel count for, actually, I guess, let's say channels 12, and that means the number of ALSA channels to monitor, I guess, for the purposes of opening the device. In case there's padding or something, you know. Okay. And we're going to need some like option parsing and stuff here eventually, but okay, that's hard. That's very hard coded. I also am not sure we want to use we could use the device tree compatible, or we could have a separate thing in the device tree like the AID, but I guess compatible makes, well, no, see, here's the thing. For example, let's say we can support a device that has the same AID as a previous one. It's nice being able to do that in Mini. without changing user space. Though, then again, the speakers don't really matter, and we can push updates to these packages pretty quickly. So maybe it's not that big a deal. Maybe it doesn't really matter. So I'm fine using the compatible, but we probably want to use an actual like strip thing there. Let's see, Rust. How does Rust work? Is there like a strip left? Strip prefix. Match read to string. Okay, compat. I think for this kind of, it's a safety daemon, right? So basically, if anything goes wrong, we are going to panic, which means I think we can just expect. So it'd be something like net machine equals read to string dot expect dot strip prefix and then dot expect. And then you want like a split once, I guess. At a null byte. Actually, split 1 0 expect and then I just want the first one. Do I even have like the Rust LSP stuff here? Do I even have LSP enabled in Kane? I think I don't. Hold on, let me see if I can do that. I think I have that plugin. Yeah, okay. Probably don't have this configured properly. I don't even know how you do that. This would be nice to have some formatting. Rust Analyzer. Do I have Rust Analyzer installed? Apparently I don't. Okay. Do I have Rust up? Yes. Maybe I should just like rust up update. Is this a thing you add or? How do I get rust analyzer? Components. Okay. Okay, and then I think I actually need to. No. Oh, it's in rust up. Okay. Stable. I guess I just use that. Cargo bin. Why is that not even symlink there anyway? Ah. Cargo bin. Okay, that did something. Shortcuts. Let me make a shortcut for formatting. Oh, so I had this Clang format one, but that's actually, if I'm using it SP, I don't care about that anymore. I care about the SP client. Let's put it on there. Okay, that makes sense. But that should be formatting this. Why is it not formatting that? Oh, okay. It was still thinking. Yeah, that's the format I would expect. Okay. We don't want to hard code a hardware device like that. We're going to have to enumerate these things. But actually, we do have a name for these things, right? Yeah, and we should mostly call it the same thing like that. Actually, we should have it in the config file. Oh, but no, then we can't symlink them. Maybe we should just take the compatible and just have the rule that the ALSA devices always have the compatible names. But then this is J314S, and we want to drop those suffixes. Because I don't think those suffixes are ever going to matter for speaker purposes. Yeah, but the J could be like a different number of digits or something at some point, right? So I need to like. I think I want a car array searcher. But what I really want is what I really want is that .r strip, and then whatever that is ASCII thing is defined in is ASCII alphabetic. Okay, that makes sense. Okay, main model, get machine, config. I want some logging and stuff. How do you do like proper logging in Rust? Is there anything in STD or great for it sucks? Okay. Because I would want something that can like log to syslog, but then again, if we're using systemd, who cares? Standard output goes to syslog anyway. So maybe we should just use like standard output and it, whatever general D does with it. Though I would want to log to like global syslog when we get like a temperature limit. There's syslog. There's a syslog crate. Honestly, I don't know how you write like Rust command line utilities. Like, is there like a cheat sheet for how you do command line parsing, how you do logging? Oh, cookbook. Okay, that sounds useful. Template for writing daemons in Rust. That looks quite useful. I think everyone just does it their own way. Okay. This looks like it might be a little overkill, but it probably has... Yeah, okay, and probably has at least some useful... And really care about signals. I use clap for command line parsing is great. That sounds... Yeah, this uses clap. Okay, let's go with clap for that. Which means we need to put that into... How does one do that? Cargo something something. Is that how you do it? Cargo at clap? Yeah. Okay, so that can go in main. Why is that insisting... Why is that putting the STD thing at that? What? Oh. Okay, I'm not... Okay, I'm not sure what that was about, but okay. IO, thread, sleep time, clap, app, arg, helpers, type, safety monitor, use crate types. I look at that, but I'll drop the device from that. Drop the PCM from that. Config there. Blah, 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 blah. Well, let's see how clap works. Okay, so you need a struct from that. I'm just going to copy and paste things. Path to the configuration file-based directory. I'm not sure if we want to use that log crate. We do want at least some log levels, though. Is the log crate that bad? Also, this is apparently archived, but whatever. It shouldn't be that bad. And this is using YAML config files, but I'm fine with INI, so we'll keep that. Okay. Version, probably want to have a global version somewhere. I assume there's also like magic crates to get this from Git or something, but I don't care about authors. I want to look into the derive feature of Clack. The log crate is standard IML. Okay. There's the option to automatically derive the command line terms and struct fields a bit more involved, though. Okay. How does that work? Oh, I see. Okay. I assume I need to edit the cargo tumble for that. Is that features? Is that how you do it? Dependencies. Oh, it goes into the, okay. Oh, and then Alsa is in here also? Okay. Features. Oh, yeah, sorry, what was I doing? Features, what was it called? Derive. Clap derive. Okay. Args, sure. Short, long, no author. There's a version, about, long, about. Okay. Does this even need to be pub? I don't think so. Arg, short, long, config path. Does path buff work for that? Well, let's find out. Well, let's see what it does with the max log level. Short, long, default value T, I guess. I'm just going to guess. Just like that. Need get machine, get drivers. We'll see about that. So I'm tempted to call it speakers. Just because driver has more than one meaning in this context, and I'm kind of confused. I know it's the right word, but okay. Max log level. Is that a Git submodule, by the way? No, it's just in there. Yeah. That's fine, though. We can vendor that. We probably might want to vendor that with all the extra stuff we're going to be needing. So how do you use that? Just parse. Okay. Main. Args parse. Model. Now, I have to clean some of this up. Just about to do in here and see if that makes it compile, I guess. Lots of failures. At least it's fast. No app in the root. I guess that's an old demo or something, and this is all changed. Okay, struct args redefined here, right? Because it's slide options. Oh wait, this one uses clap parser apparently. And then I guess we need log. And log level filter is not a thing. Okay. That is not a okay, it's just level filter now. Path buff. Okay, that's in standard. Asahi device, yeah, we'll do that in a bit. Let's just comment out all this for now. Missing ELTR magnet, new speaker, that's in types. Our strip is not. Oh, that only works. Does that only work on strings? Uh, oh, it's trim. It's not our strip. It's strip suffix. Is what that is. Okay, value parser. Okay, that's interesting. That's a lot of ampersands. So level filter doesn't work. Not terribly surprising. Is there an example of doing that? Why didn't I clean Rust? And that's a recent article too. Okay, so there's a conversion thing. No. Oh, verbosity. And that's in clap verbosity flag. Oh, is that another crate? That sounds reasonable. They call it cargo because you need enough crates to fit a Panamax class ship. Yeah, I had a lot of trouble when I was doing the menu thing, making sure that we had like a very limited set of dependencies, and they were all vendored and in subdirectories. This is not user space. I care a lot less, but I still don't want this to explode. Okay. Right. This is Rust. No semicolons there. Okay, mismatch types. Strip suffix. Why is strip suffix returning an option? Oh, okay. That's not what I want though. I wanted to optionally. Oh, trim and matches is what I want. And I guess I need to own that. Okay. Cargo run. Wait. Speaker safety 2. Why is it 2? Is that like the cargo version or something? No. Oh, yeah, name. Wait, why is it 2? Okay. Let's call it speaker safety D. Okay. So next I need a default on config path. How does Rust do like build time configuration flags? Do you even care about that? Because I know some distros are going to want to put this somewhere else. Anyway, how do we do defaults with this clap thing? So default value T. Or just default value? And this shouldn't even be etc because this should really be user share. And then we need the prefix somewhere, the user thing. So maybe that should be option path buff and we fix it elsewhere. Because otherwise, I think getting this configurable is going to be a bit painful. Oh, there is a dirs crate. Okay. Okay, but this is for like OS independence. But this is kind of overkill because this is only ever going to run on like POSIX systems. What I actually want is just an overridable, like configurable directory. Rust prefix CFG. There's probably a CFG thing we can use. Package or something. Maybe there's probably some way of doing that. Perfecting Rust packaging. No, that's... I know CFG exists, conditional compilation, but what I actually want is to pass a string like that. Come on, there has to be some semi-standard way for like Unix prefixes. And variable compile time. Okay, yeah, that would work, but okay, Debian wiki. This might be useful. No, that doesn't look useful. So there's the cargo install stuff, but that's kind of... Googling this is so hard because they are like totally boring names. Cargo C build, prefix. Well, that's for C stuff, though. Yeah, I mean like this there and stuff, yeah. Well, basically, I want prefix so I can have the default configuration path be based on that. Basically, it should be user local share speaker safety by default, and then, when you package it, it should be user share speaker safety or whatever. Okay, so let's just say it's a build time configuration string. How do we... There has to be some way of doing this. Do you have a link to the Fedora stuff? If you sent a link, it didn't go through because YouTube. You can send it on IRC. Or you can just like break the link and it'll probably work if you like obfuscate it. I guess people use env. Sent on matrix. Actually, it's in here. Just making it a bit smaller so we don't have too much backlog showing. Okay. So env install, yeah, okay, install root, but there's no passing the environment into the actual build anyway. I assume you can't get this root. And it's not useful anyway because that's build root. And prefix isn't passed anywhere. So okay, I guess that's not useful. Yeah, clearly. Okay, so what I want is option env. Oh, but there's no way of having like env with the default. Well, I guess you can just use compile time. Yeah. Yeah, that doesn't need to be in the macro. Const config dir equals option env. Prefix. Actually, just say conf prefix option and prefix. And what is that? Okay, or something. Yeah, Mason seems like a bit overkill for this one. Or okay, or else, unwrap or. I guess it'd be user local by default. I have no idea if this is valid Rust. We'll see what cargo says. I don't care about supported. We'll see about that. I guess I need prefix to be 2 owned here. Ooh, add is not const. Well, that's painful. That's for literals. That's not what I want. And of course, it's another crate. Well, no, concat is going to be like concatenating tokens, right? Literals, but this isn't literal anymore. It's the output from option env. And there's an unwrap OR. Default, yeah, okay. I'll just add it at runtime. And so now how do we log some stuff? Let's start doing some logging. How does log work? I need to, where was that? I had some, okay, yeah, that. Verbose. We don't have commands in this case. It's just set global verbosity, mod app. Where is that passed? Okay, but how does verbosity work? I mean, sure, I'll buy a one cell, but how do I pass? Oh, okay, verbosity. Okay, this is overkill. What? Is there no way of just like using the log crate and giving it what? How does the log crate work? Yeah, or warn info debug. That sounds right. So what sets the verbosity for those things? Oh, log crate is the interface, and log is an impl. Okay. Okay, so env logger, simple logger. And there's syslog stuff, but that might just set up logging how you wouldn't see. But the simple logger one might work though. timestamps correct when logging to a standard error. That sounds reasonable. Let's try it. Okay, simple logger. And then it's not a level filter anymore. It's just a level that I need. Verbosity. Oh, no, that is the... I think. No, that's the clap verbosity flag. Okay, how does that translate into log levels? Verbosity, log level. Okay, just get the log level from that. I think I need that. I don't know what happens if you don't initialize it, but expected path buff found string. Okay, yeah, I need a what's a path buff? Oh, I can push stuff like, okay, yeah, actually that's kind of nice. And then I guess I want an unwrap or with like a function from a closure. Yeah. Path buff. And then that doesn't need to be rooted like that. I think it's fine to do a string like that. Okay. And now how do I get the log import? Where's the log crate? Okay, I just need to import them like that. Or I can just... Wait, does that actually work with... Does that work with macros? Unwrap or is not yet stable as a const function. Huh. Okay, fine. Oh, we'll do it like this. Okay, now it builds. Panicked. Not yet. Yeah, okay, we got that. Okay, starting up. Okay, so the log stuff works. Do I want to use log : or I guess I would do one to import the things. Debug, info, what are the others? Trace. What are the levels here? Level. Error warn info debug trace. Let's just get everything and clean up later. Debug starting up. I guess that can be info. I assume this is format friendly. Model. Path does not implement display. Two-string lossy. What's the difference there? I guess we might as well use debug. It's just logging anyway. Okay, that I'll go with that. I also am not a big fan of UTC in there, and generally is going to add timestamps to things anyway, so I think that's a bit redundant. Like if this were logging, to a serious logging system, you'd want UTC, but in this case, it's just a daemon. I think I just want to disable timestamps if I can. Or was that simple logger? Yeah, the UTF-8 thing makes sense. Documentation, init with level. I think I need to use that. Instead of init with level, I think I just need to use... I think I need to use that and then configure it manually. So it would be, instead of from environment, it'd be new with level. Yeah, it's one of those builder pattern things. With level, init, unwrap. Then we want without timestamps. With level, oh. Okay, I want to level filter on that. Oh, and then I guess, oh no, yeah, it's only going to be enabled if we have any of that. Oh, okay, and then I don't, fair. That, I think, is going to do the right thing. Yeah. And then we don't have the timestamps anymore. Okay, that makes sense. Honestly, it doesn't need the program name either, but... But I'm good with that. Starting up config path, model, J314. Model, okay. Let's call this config base. Is there a format macro I can? Oh, you can actually. Wait. How does path buff push work? If path is absolute, replace the current path on Windows. Okay. Extend the existing path. And then there's set extension. Oh, set file name. Right. So I can just push model and then set extension. Yeah, I think borrow config. Oh, yay, borrow checker. Okay, except, wait, 2 dots? Oh, okay, because the extension includes the... Okay, that makes sense. Model, conf. Okay, so then I need to set the config base to dot. And now let's actually load that. Any new CS, how do we load that? Get drivers. So I need to do config read. Was that in here already, or in helpers? Okay, we got all the parse stuff there. I guess the actual load wasn't there yet. I guess I want load. Yeah. Yeah, that makes sense. Cool. Parsing works. Okay. So then I need to parse the configuration file. So I only really need channels here as the global. We're going to assume the card then is the uppercase name. Rest string upper. I assume there's a to upper or something. So you have helpers, open card. That opens the controls, and we also need the PCMs and stuff. Info opening control device. So then get drivers, we want actually we already have this called speaker, so I guess we might as well call it where's get drivers? Oh, that wasn't here. Yeah. Speakers. That's kind of yeah, I guess we just need to filter that. Wait, vex string? Oh, okay, that's just the list of drivers. That's fine. I just need to filter these. I assume this is all nice and starts with. Is there a Rust iterator? Is it like a filter map at the same time? Yeah, filter map. That's actually what I want. And that returns an option. Yeah. A dot. And then I need to rstrip strip prefix. Yeah, and that returns exactly what I want. That. Let's do speaker names. Move that to the bottom. Drop that. Drop that. Actually, let's do len on that. Opening control device. Let's call it CTL. And then this actually needs to check. Actually, it's more like that speaker names. Speakers push new speaker. And then in the helpers, we need to get the group too and some other stuff. Yeah. ISChan is it doesn't really need to be 64-bit, but is there a reason for doing that as i64? Oh, does that make sense? Or is it only because parse int is doing that? Oh, okay. Fine. Cool catching you stream. Want to say you've been inspiring me to do programming and tech in general. Thank you. I'm glad to hear that. Name, group. I guess that's an i64 then. And then I guess the sensible way of doing the groups is just having an equivalent of hash map. What is that in Rust? Hash map, yeah. SIMD lookup, that seems like a little bit overkill. But okay. Let's see if the type inference knows what to do with this. Brian speaker names. Speakers push, new speaker. Pub group. Let's make those public a bit easier. Oh, and then the name. No, that's the config. Okay, this has to go in here then. Let's call that name. And we can call these section. Yeah, I mean, at this point, we're just initializing. So, basically, my idea for the daemon is that if anything goes wrong, we panic because the kernel is going to be monitoring we're going to have something in the kernel that has both watchdogs and just checks that someone has the device open for safety. And if it gets closed, it's going to go into safe mode. So, because the whole point of using Rust is that if anything goes wrong, the worst thing that can happen is a panic. So my idea with this daemon is that just anything goes wrong, we panic, and the kernel is going to go into safe mode. So hashmap new. And how do I need like a get or set. There's no get or set. It's not exactly what I want. I guess I can just say contains key. New speaker, if speakers contains key just call this speaker dot group speakers dot insert speakers unwrap dot push speaker. I think that makes sense. And then the number of speakers so we're going to do a sanity check here. Speakers values. And now Rust iterator. Is there a reduce thing? I hope there's a reduce thing. Yeah. And that returns an option. Unwrap. I guess fold is the same thing. Then you get 0 on that. And then we don't need any unwrap. Yeah. Equals okay. Just make sure that we actually got everything in there, because if we don't update some speakers, that's pretty bad. The contains key logic into speakers map entry. Oh, entry. Oh, interesting. Actually, doesn't vec implement default for an empty vector? Yeah, it does. Okay, so just or default will do it. Oh, right. That returns the... yeah, okay. So then they can just push. Cute. Okay. Okay, that's just old junk. Mismatch types. Okay, I need hash map imported. I also missed something here. Oh, yes. Why does that go to the top? That doesn't make any sense. Can it find value card in scope? Right, because I called that CTL. Okay. Yeah, Nielsen 2 owned on that. Yeah, sure. Okay. Actually, is assert compiled out in Rust? Is that supposed to be only for debugs? Okay, assert is always doing it's going to be disabled. Okay, yes, so that is what I want. And then I can just have another one then, which is that... Actually, let's just say speaker count equals that. A bit easier like that. Speaker count, and then assert 2 times speaker count is less than or equal to the channels, and the channels is helpers parse int CFG global channels. Probably want to have like a global settings thing somewhere. Channels I64 pub. What other things do we have? A T-ambient. And a T-safe max. And I can just have a parse here. Parse int bin T-safe max, parse float, config globals, T-ambient, T-safe max. That should be fine. Oh, I know why it's doing that. Because we need a... There's... Yeah. Because it's a global comment. How does that work with... for multi-line comments? Is there a syntax for that for multi-line comments, or do we just want to do it like that? Okay, it's like that. So that's why I was doing that. Vecstring is not an iterator. Filter map into, okay. Where was I? Speaker config. That needs to borrow the name. And then we have usize and i64 and stuff. Yeah, let's. So let me look at the helpers because we might just get rid of those parse float things. Parse intro to parse plus a sec. Yeah. Can't we just make this generic? Because I do want at least some reasonable error message that tells you what the key that failed is. But then we can just have that. And then all this needs to do is implement from whatever inner is, which is... Oh, wait, there's a config get int? Okay, hold on. That was the ANI crate. And we can also just get section. Which probably means we should just pass that to the getter. Okay, where did get int come from? Oh, it's config parser is what I'm using. Is it? Yeah, okay. Actually, the Rust any looks better, actually, but okay. Okay, so parsing makes sense, but then we can actually just have a type here. And then T just needs to implement from i64. Actually, try from i64. And so then it'll be config, and I think we can just simplify this. Config get int section key dot expect. And then we want dot try into missing or invalid key. Wait, no, get int. What does it return if... Oh, this is a result. Oh, wait. What does it return if it doesn't exist? Oh, okay. If it doesn't exist. So expect is the invalid key case. Section key. Expect missing key. Try into dot expect out of bounds, and then we let the parser Rust format do its thing, and that looks a lot better. And then parse float. That's always going to be F32. We're not using F64s. Does F64? I guess we might as well check bounds on that. From F32, I want the opposite of that, but 32 from F64. Is there a try from? From try from. There's no try from? Okay, then I guess we just need to assert is finite. Get float section key, expecting invalid key, missing key. Actually, more like invalid value. Okay. Where are we at? Invalid value format. Found string. I need to borrow those. Oh, right. This also needs to be format. Try into cannot be formatted. Required by expect. Well, that's interesting. Oh, I just need a bound on that. Ooh, well, okay. I'll go with what the compiler says. That was like 64 to 32 is what I was trying to do here. Not the integer one is fine with those conversions. And now filter maps speaker. Is there I think it was a collect thing in there or something? Collect. Yeah. Okay. Value vex string cannot be built from iterator item and stir. filter map dot to string, I guess. Oh. I guess I might as well just do filter map and then dot map again. Okay, open card. I need to borrow that. Yeah, that hash map didn't. It doesn't like that stuff. And then in this case, I actually want this to be usize. And then we're going to be parsing these like that. Because now we can actually parse things in a more generic way. So you want usize for these kinds of things. Okay. What did I just break there? Colon. Push speaker string was not string, sorry, this is a speaker. Okay. Filled, what? Fold. Oh, I need to borrow that, I guess. Okay. Left woofer 1 temp limit, missing key. Interesting. It's T limit, not temp limit. Okay, got past that. Call this PCM. Open PCM. And then we need to know the VI sense PCM. Is that always fixed? I guess it's always fixed. 02. Was it 02? Was it always 2? No, I think it was. Oh yeah, 0 is the codec, 1 is the playback, and 2 is the capture. Yeah, okay. That should probably be in globals, actually. And channels is also usize. And then I want to actually parse the globals here. And then we can pass the globals in with the safety monitor. And we can, for example, assert. Why are there braces here? That makes more sense. So we assert we have those channels there. So run. Yeah, so this needs to go in group. For group in mut speakers. Does that need to be mut speakers? Isn't there like iter mut or something? Oh wait, no, that's a hash map. How do I iterate over a hash map? Iter mut should do it. Okay, so it's just key value in that case. Val in speakers iter mut. And then buff. Is that times channels. That should probably be an option. You can leave it there for now. 16. And then this channels thing goes away because we have globals. And then that comes from globals.channels. And then the PCM name is just the format, and I can do actually just do it like that. Device. I try to run persistent values and async and async. There's not limit sync. Yeah. What do you mean by persistent values? Like storing them in a file or something? The temperature seems to get freed between runs of the loop. But I mean, it's not a closure. I mean, you need to store it. Yeah, because I mean, we need to put it here, right? Like there's no structure storing things, right? So T coil, T magnet. And for now, we're going to assume T coil and T magnet are both 100 on startup, and it should go down over time. And that's like a safety thing. I mean, worst case, we should expect it to be like the highest value. But if you're actually overdriving the speakers, I think that's going to like jump up pretty quickly. well, yeah, not the safest. We might want. This is why I was thinking that we might want to actually persist some of this. But then again, this is only really going to matter on boot, and like how long does it take for the temperature to drop? Well, the magnet is pretty slow, so that's a bit tricky. Oh, but no, we're going to have a maximum magnet temperature anyway, so we should compute that. Yeah, we can actually compute that. So we're going to say the T coil is 100, and then the T magnet is what the magnet would end up when the coil is at 100, and that is actually just the fraction of the thermal resistance. So we can just say lit mut. Yeah. So then we can set this to like 140 or something, or even to the T limit. But then we know the magnet's never going to be above that anyway. And that means that it's very quickly going to drop towards T magnet, which means we shouldn't really get speaker throttling, a few seconds after boot, which is probably okay. Yeah, let's do it like that. We're going to need more stuff in there later anyway, but... Whoa, what happened there with it? No, that's... We have to calculate instantaneous power and current. We can't just average them. That doesn't make any sense. We have to calculate instantaneous power and current, and then we can average that. Otherwise, we'd have to take RMS, but even RMS isn't going to work here. Yeah, no. So we should store these max numbers in there somewhere. Yeah, but you don't want the average of the samples in the buffer. Yeah, but you don't want that. Like you don't want the average of the samples. You want the average of the power, which is both samples multiplied together. And also, I'm thinking I want to run the model per sample anyway, because that's going to be more accurate, and the CPU difference is going to be negligible probably. And then buff should just be a thing like that. Is there like a like Rust. I want like a range with a skip or something like that. I think there's a way of doing that. Step by, yeah. For sample in step by self globals. I think we're just going to copy globals because those are constant anyway. Channels. I still need to index into the VSense stuff. Chunks might work. Yeah, that might work. Rough chunks. Yeah. Yeah, that's a nice one. Cool. So for sample and buff chunks of samples are for yeah, it's fair to call it sample. And make sure we don't have any remainder at the end because that'd be bad. Let v equals sample self dot yes chan I sample is chan, and I want to divide that by as of 32 divided by 36.8. And we probably want to have the v scale and I scale settings also in the config file, which I know Apple has, so we should have copied those. And those are in CL in the calibration key, but we actually want those vmon scale and imon scale. Though those could be different on Linux if we use different settings from macOS, but we probably no, they won't. These are static, I think. So vmon scale and imon scale in CL. Let's just put them in manually. And that would be cal CL. Yeah, they're just straight out of the datasheet. And I verified that they are what we expect. Yeah, there you go. That works. Like I calculated them and it was the same as what Apple had. So let's fix those manually for all these. And then we need those also in here. Helpers, was it? No, types. And we also want, okay, so we actually want a like super extra safety. Yeah, we probably want to say, okay, we have a T limit now, T safe max, and yeah, we probably want an actual like a temperature. Basically, if some setting is wrong, then the temperature is going to go higher. Especially if some of the output like scale settings and stuff are wrong. Potentially the temperature could go higher. And if that happens, I think we just want to panic and let the kernel go into like proper safe mode. Yes, there's a hard temp limit headroom. I'm going to assume that's under. So let's also copy that. Let's call it Tmax. And that's going to be, let's just call it T headroom. And that would use the same settings as Apple. And I think it's always 10. That's not what I wanted to do, but okay. Yeah, it's always 10. So I'm going to assume that's below the T limit, which means that we're going to be limiting up to 130. And then if we reach 140, somehow we panic. Which means the limiting isn't working properly. And then so the T code is T limit minus T headroom. Yeah, mutant codec safety mode would make sense, but I guess do that and then panic. But at that point, what we really want is like a panic handler that does that. I mean, we could just set the codec safety mode would have to be a separate control. We could just set the volume to like really low. And then we can have the kernel side, when the device gets closed, we can have it max the volume so that if the daemon set it even lower, it sticks at an even lower value. So then that means that the kernel's sort of safe default can be something higher, like something that is, calculated to be safe at all temperatures, at all, inputs. But, so you can get some sound without the safety daemon. Sort of not assuming that something went horribly wrong. And then if the daemon calculates that something did actually go horribly wrong, then it gets set lower than that, and the user would have to like manually increase it. Or run the daemon again, and then it would at least, try again. But then we also probably want to make sure the systemd like restart stuff is set to at least have a long delay between restarts, so that the user like the audio cycles or something, and it's clear that something is really wrong, instead of just quickly resetting. And then, as long as that time is at least a few seconds, then that's enough time for it to cool down enough that this limit here is going to be okay. Anyway, v scale, I scale, p equals v times I. And so then I need to split this into two things. Because I need to the loop needs to apply the volume limits as a group. And I'm thinking that for the groups, I actually want an actual structure here. Because I need to store the global volume, and then I need to figure out when we update it. Speaker group. That's going to be really simple, though. It's just going to be speakers. Is a vec of speaker, vec of type speaker. Gain is an F32. And I can derive default from that, I think. Yeah, I could have the ALSA structures here, but actually I'm just thinking that I'm just going to have the group calculate the gain here, and then when the gain needs updating, it calls back into the speakers and for the gain, for the ALSA update. That way I can keep the ALSA stuff here, which is not bad. And then it would be dot speakers, dot push. And I guess I can just call this groups. This is PCM name. And then it's groups, itermut index group for speaker in group speakers itermut. Let gain equals 0 F32. Gain equals gain dot min speaker dot run buff. And then I guess that doesn't need card because it's not going to actually change anything. Yeah. So just buff. Speaker model, I guess. And then because we also probably don't want to actually update the... Yeah, we obviously don't want to update the volume more than once per group anyway. And then we can optimize this saying if gain does not equal group.gain, Then we do the update. And that means that when we initialize the groups, we probably want to actually set the gain to something crazy. So then the default would actually have to be nan or something like that. Yeah. Iter mod map reduce if there are too many. Okay, that works, but fine. And then unwrap. That's all very rusty. Interesting. But I still need this check here, which does mean I need, I guess instead of a default here would be speaker group default. How do I get nan? F32, I saw something there. What? Yes, that. Actually, min. Oh, sorry, nan, yeah. Oh, that doesn't work. Then I don't derive that. For speaking, yes. So then we do actually want to do the updates there. I mean, I guess I can just map that again. Update gain. And then there was like a thing to like run iterators. Like consume iterators or something. Oh, for each is what I want, right? Yeah. We are going to need something to avoid like spurious updates here eventually. Actually, I'm not even sure if we need to keep the group gain here. I might, just for information purposes here. So if group gain is equal to 0, then we are going to log a warning. I probably want to throttle these eventually with some kind of like hysteresis system, but I guess for now that's fine. Get rid of the to do on that. Okay, let's see how much stuff I broke. A lot of stuff apparently. Notified value is card in the scope. Okay, that's the level stuff. It's not called card. That's just run. We don't care about level there. Let's just move the model there, and that returns a gain. And I guess I want the gain in here in F32. And then I will want some, thresholding on that. If self gain is less than actually, I can just implement the hysteresis here. So that's just to make sure that when we get to 0, we actually get to 0. Sorry, is greater than minus 0.01. Because, otherwise it's just going to take forever to actually reach the floating point like steady state. Yeah, I think we want some hysteresis here. So we want the hysteresis on the gain or on the gain or on the temperature? Okay, that means we want another temperature value. We want like the safe max. Maybe that's what Apple was doing here. Maybe that's what the offset is for. So let's have a T hysteresis in there. And that would be in globals, which is in here in main. I guess that has to be pub. Sorry, not there. Would I put globals? That is in types. Okay. So then basically the model is going to be, we have the specific speaker, T limit and T headroom. So we have the actual temperature here. And I guess if at any point the T coil, if self that T coil is greater than self T limit And this is what probably should go into safety mode eventually, but for now, let's just do it like this. Does panic take like format stuff? Yeah. And this should really never happen, but so then we have the temperatures. We're not going to run the gain updates until the end of the buffer anyway. So once we have the final temperatures, which could have been getting hotter and then colder over the buffer calculations, and I'll have to move that over there. So now we calculate the gain. So then gain would be I still need to calculate the we need the max gain reduction. So that needs to be calculated here. And the way we calculate that is by... Actually, I can just do... I hope I can do that. Except also iFace is going to be an issue. Name group, and yeah, let's do it like that. Speaker state. ST limit, ST headroom, STR magnet. Makes it a bit easier to read. I guess technically the state would actually be, yeah. Just the gain, the T coil, T magnet, and then the computed properties. So we can move these to the top. And then it's just like that. Speaker T limit, speaker T headroom. Let's see what happens with that. I mean, gain. I probably want to copy the global stuff here. Sense PCM. And I also need to grab that. I guess I can just derive copy for that. And then I probably want the debug on here. So we can just print that out as this. Did anyone manage to share BT devices from macOS 13 plus to Linux? Jan now is working on that, I believe. I think that needs to be a deref. Okay. So then in globals, we have TMB T safe max and T hysteresis. Gain lower equals actually, you can just calculate the temperature as a hysteresis thing. So T coil, T magnet, and TH coil, T coil hist actually, and T magnet hist. So if self.t coil is greater than self.t coil hist equals self.t coil, else if self.t coil is less than self.t coil hist minus self.g, actually this is self.s. Let's just take a state thing here, make it easier. Mat self.s s t coil hist t coil, else if s the t coil is less than let's actually solve g t coil hist t coil is less than actually I can just say self dot gain equals self gain max self t coil hist self t coil hist max dot min actually it's just called T hysteresis. That's what I want there. Yeah, I think that's the right calculation. And then T magnet would be the same. Okay, yeah, that kind of makes sense. And so now we have the actual temperatures. And so then we say the gain is again, like even this doesn't make any sense to even care about the magnetic temperature, but just in case, we're going to do that. And then the gain would be like a linear map of this from the T safe max. So temp minus T safe max is the gain reduction. Self G T safe max temp T safe max over. Actually, we want another assertion here. T limit minus T headroom is strictly less than globals dot T safe max. And I probably want to add some logging functions here to print the speaker info. And so the gain becomes temp T safe max divided by the delta there. So T limit minus self T headroom minus self GT safe max. Let's call that reduction. Gain equals minus actually self dot. Did I call it min gain or did I call it? That wouldn't be in speaker state. That'd be up. Well, I can calculate. Yeah. I guess I want to calculate that. So I need to calculate the min gain, and that is basically based on the. I need to get a max power reading out of this. And for that, I need to know the actual power power limits at the maximum gain scale. So that's something that has to come from the globals also. Yeah, so peak power is what I want. And that has to come from the that's what we need the speaker. That's what we need the speaker resistance for. So we set that to amp level. And that will be in dB volts. And then, so that's why we need the nominal speaker resistance. Okay, that makes sense. I don't know if that has our shunt added to it. We're going to say it doesn't for safety. Actually, no, that is the same for the tweeters, so it shouldn't be. Well, maybe it is for these. Oh, and also, I just realized that the resistance is going to change based on the temperature. So we actually can't assume a constant resist. No, it doesn't matter. We have VIE sense. We're measuring power. But we do need the resistance to calculate the maximum voltage at which, yeah. And so the resistance is actually going to increase as temperature goes up. So there's actually going to be, let's see, is that going to work? Or is it going to oscillate or something? I guess we'll find out when we test it. As this might actually oscillate if I'm thinking. It's basically a P controller or something I'm building here, right? So the resistance is going to go up, which means the power is actually going to go down as the temperature goes up. We are measuring power, though. It says that the gain reduction is... Oh, no, but the gain reduction doesn't really have anything to do with power output anyway. It means that in theory, we never should actually hit the minimum gain because we are never going to hit the temperature where that happens. So that's okay as long as it doesn't oscillate. Yeah, we'll see what happens like empirically. So let's just play it simple for now. So max power is globals dot, and that was called tAmbient. So the delta is new speaker dot t limit minus speaker t headroom minus tAmbient. Max dt, let's call that. So the max power is going to be max dt divided by new speaker dot tr coil plus tr magnet. Same deal as there. And so, blah, 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 blah. Yeah, then we need the amp level and the Z nominal, I guess. Just 3.2 for these. Let's put it here. And then the amp levels, that's what matters. So we had those. I had that somewhere in the Jupyter notebook, but I can also just look at the kernel code for that. I think it was half a dB for each one. Or actually, probably just going to look at the... we had those limited anyway, so... Oh, wait, no, they were hard-coded to something. Right, we were hiding them. No, it is here, amp gain, yes. 1550, was that the same for all of them? Yeah, 1550. And I think that was already limited. We could read that. Yeah, we probably actually just want to read that. amp gain, and then it's guaranteed to be synchronized with the kernel, which is a good thing. And then also iFace, get level, set level. And we're going to do a get into dB, convert to dB. Okay. And so vsense and isense, we just want to make sure are on. And I'll probably have to change these values anyway, but we can leave it like this for now. vsense, isense. It's amp gain, control 32, readv, self, amp gain. Name. Set level. Okay, I think that needs so then we can get amp gain. Amp gain. So peak power, and that's an interesting one. We know the amp gain. We need to get the resistance out of the config file also. The nominal, and it's 3.2 for everything apparently. So the peak power, we have the gain in decibels, and that returns a F32. Okay. Where's I need my math power stuff. And that was in dB volts, I think. Is it TDA or TAS? Yeah, that. Yeah, it's dB volts. Okay. Rust. Pow. Where's the pow function? Is it just in math? Oh, it's just .pow. Okay. Amp gain divided by 10 is, yeah, that should be in volts. So this gives me the peak. I think I have this right, decibels. Wait, no, this was measure. It's 20. It's 20. 20 log. 20 log 10. Just double check that, but I think that makes sense. Yeah, divided by 20. Okay. So that gives me the voltage. What was the formula for that? The current is that divided by the resistance, which is speaker Z nominal. And then we multiply that again by the, yeah, so I need that pow 2 again. Which means I can just do that. I think that's correct. Okay, let's get the logging functions in here also, so I can actually print a bunch of this stuff to make sure it's reasonable. Let's print the basic information. Peak power, min gain, so then that's the trick here. Peak power minus max power And I need a log 10 on that. There is a log 10. Yeah, that's log 10 times 10. And it's never going to go above 0 anyway. Let's put actually the units here. Group that, max power, peak unit, max temperature. What is that? Uh-oh, yeah. And that's... Okay. And so then the gain is min gain. Reduction. And in this case, we are not yet doing any like attack release stuff. We would do that here. But let's just do it like this for now. Wait, what's this with the alpha VC? Show the power now. Isn't that just the hard-coded value from the Python? But in this case, it's in the sample rate, so... let's actually have a sample rate as an F32 here. And then in types, no, in main, when we open the PCM, it's in helpers. I don't think we need to pass channels as a reference. But then I'm going to have to check the params somehow. Or we just do the thing where we estimate the sample rate from the incoming data rate, which is not a terrible idea. And then I don't really want value or in here. Let's force it for now. The work of speakers from maximum weekend temperature working for speakers on Linux in general, yes, it should all apply to whatever other machine needs EQ and stuff, especially, but also the safety stuff. If some other embedded system needs it, it should work. Where is that? Where's that value or stuff? Oh, and lib. Oh, okay. Yeah. So I need to. Sound PC hardware params set rate. I guess I can just get rate from that. Can I read it from the PCM? Oh, current. Okay. Yes. Sample rate. Let's do a print on that. Okay, this is wrong. This is the temperature coefficient. Yeah, it's TC plus step. Yeah. So those are going to be at the top. Let alpha VC equals step equals 1 divided by sample rate. Alpha VC equals step divided by self dot. I call it tau, or I guess it should be tau. Let's call it alpha coil and alpha magnet. So then the targets. T coil target and T magnet target. T ambient plus P times self dot TC magnet. Is it called TC magnet? TR magnet is self T magnet plus P times TR coil. And then we need to update those through the alpha. Just T coil. alpha coil plus T coil times flat coil and then T magnet target alpha magnet T magnet and self S. TR quote. Okay, this is starting to make some sense. I already had S, so it's not self. Let's just call it S. And we might as well log the average power, the average instantaneous power. And don't actually need this right now. I will when I implement the attack release, though, I think. Yeah. Well, actually, no, I want to implement the attack release before I get to... like, I want to do that at the temperature level. Reduction to T limit T safe max. Wait, reduction. Did I do that right? Yeah, 10 minutes T safe max over T limit T safe max. Right, and that can go negative, so I need max 0. And then that's where I want to do the... Yeah, if I do the... if I do the attack release stuff on reduction... that will be reasonable. Because that's going to go negative, like, at... to some reasonable value as it goes towards ambient, but it's not going to, go to 0 or something. So yeah, that should be fine. Gain, coil, just yeah, okay, I don't really care about that. Run, and then I want the function update. And that's where we take the gain of 32. Okay. This is going to be hell to compile, isn't it? Speaker, safety, D, cargo, run, whatever. Lots of stuff. Give me a second, I'm going to the toilet. I am back. Okay, how much broken stuff is in here? Speaker update. Gain. Yeah, this is that. Types RS, semicolon at 101. Okay. Could not read amp gain for. No match there. And I don't think we need any types here. And then we don't need to specify that. Okay. I guess it has is this gonna no, we do have that. Oh, because this cargo is it because it's using a specific Rust version? No. Is it in the cargo lock? That's a lot of dependencies already. Oh, that's for Elsa. I don't care about Elsa. Why is it loading 161 though? Failed to load workspace, cannot find sysroot for cargo tunnel file. I think I need to tell it what something about Rusty. I have Rust source. But I think the problem is that this is saying Rust 1. It's trying to load my system like Rust or something like 161.0 instead of the cargo version. I think it's because it's not setting the path. Was there an environment thing here somewhere? See if I can set the path somehow. Let's see if there's a way of setting environment variables somehow. Config page. Settings JSON. That's the default, I think. Probably not. I think it's probably because I started Kate from Kernel instead of from ZSH. Yeah, I think it's working now. It's doing something. Okay, fine. That's taking a while now. Anyway, let's go check. Yeah, it's doing stuff. Not read level for. Where am I? Cannot read level for that match. No match there. Debug coil. Unknown format trait F. How do I format Rust? Format float. I think I don't need the F. Yeah. Not a member of trait, get amp gain. Why is that even... Why is that a trait? That should just be impl lm. Also control get amp gain. Yeah, why is this a trait? Control mixer. Update is not a matter of trait safety monitor. Okay. And that also doesn't need to be that. Okay. I don't need safety monitor anymore. Okay, now we're getting some stuff here. T headroom, no such field. T limit, headroom. Okay, now at least it's letting me format, so I'm not going that not that far off. Amp gain, get amp gain. I need the card on that. Wait. I guess because that's not. I guess we can't clone that. Okay. Safety monitor, new. Speaker, new. Outside face card, set level. And then I guess I need the card on that. Let's call it CTL. Okay. What else is happening here? Should be public. Peak power. PowerF, okay. Global's not in speaker? I thought we had that. Oh, it's G. Right. G magnet. Yep. I think there's like a fix, quick fix. No, that doesn't work. Let mut power sum. I don't like how it takes quite a while to refresh every time I do that. Does 1.0 work? I think that is, it can be infallible, and then there's G channels. It's S. Okay. That doesn't return anything. Okay, it still wants that one. For the into there, I guess. Now what? Type must be none at this point. Okay, fine. Sorry. Or is it the into that I was complaining about? I can just as it probably. Okay. Bunch of errors still. Global VSN's PCM name. Okay, that's in main. It's global S. No field speakers and VEC because it's not a VEC anymore. This is a speaker group. Let PCM num chance. Where's the channel count? Global channels. And that's also global channels. Speakers len. Those channels. Sample rate. I think. Yeah. Oh, the other way around. And it probably wants E32. Yeah. Okay, fine. Yeah, so that doesn't work, but this is just the vec vec new. How do I buff dot is there a set the setlin do what I want, or what's the that's unsafe. Resize. Yeah, okay, resize. Where cap can that's called BCM now. Groups, itermat. Okay, see how close we are on the compile. Okay, in there. Oh, not unwrap. That is expect. And I need to derive defaults for speaker state. Can do it by 32 by integer. I'm gain 10. Okay, yeah, that is 10 dot, 10 dot, 0 dot, not comma, dot. Okay. Expected front string. I guess I need ampersand on those formats. Global's parse needs to be public. Then we have some mismatch types. Global's channels, I guess it needs to be into an open PCM in main. This is trying to unwrap. And then model is what I'm calling instead of run model. Like that. Okay. And it should be public. And so should be update. And group gain in main, the floats again. Okay, and then in update, I need to pass in the control. And run model needs to take the buffer and the sample rate. Hopefully that should work as an into. Then update control. Okay, I need to borrow that. Oh, there's no into? Okay. Okay, and now the borrow checker is complaining. Min gain is immediately borrowed. Oh, self-s min gain, yeah, because I'm not supposed to be using self-s there. It's just s. Guess I've borrowed that. Okay, missing key VA sense PCM in globals. But I do have it. Question mark? Why is that panicking? Oh, globals, plural. Not read element, amp gain, enoent. Left woofer 2, amp gain. That does exist. Yes, I don't need to store max power there. I also need to implement setting the vsense stuff, the vi sense. I should probably just take it off of here. Set boolean. Let's reread it and then just double check that it's actually. Surrogate Boolean, I guess, probably. Maybe, maybe not. Oh, right, it's the 0th value. Sun control, okay, well, for 1 amp gain, could not read now, but... Oh, now it's random. Why do I get the feeling this is like... Oh, is that just because the hash map is in a random order? I guess it's because the hash map is in a random order. So it's failing on all of them. Okay, so it's failing on amp gain, and that's just the very first thing that I do with it, I think. Yeah. Would be nice to... The others are working, though. Okay, so it is... a mixer. Oh, because it's amp gain volume. Okay. Assertion failed. That's the wrong assertion, isn't it? No, wait. T head minus T headroom. Yeah. No, it has to be greater than T save max. Okay. Those peak powers are not right. But now I'm realizing that it would be nice if that hash map kept... Actually, why is that order random? Is it because the any INI stuff is probably... That's not a big deal, but it would be nice if they were consistent. What are you iterating over? I'm iterating over speaker names, which is a vec that came from config sections iter. Yeah, so that's not... It doesn't preserve order. Yeah, but it's the config parser thing that is the issue here, I think. Ah, that. Okay, index map feature. Okay, I guess I can just enable that. Aha, now they are in order. And then I do want the groups to stick in whatever order they came in the original file. Actually, I could just sort this, but by yeah, I guess we can just keep them in the order in the file. So groups, speaker group, hash map new. Let's call it the B tree map. Maybe not. Okay, that should work. Now, why is... Okay, so that max power makes sense. I think that's about what I expected. Peak power is nonsense, though. So peak power... And also that needs correcting for... okay, minus 60... Okay, that's wrong. Unless these are... No, they're not. Should be like 1550. Something is weird there. Oh, it's wrong. Okay. Okay, now it's right. 15.5. Peak power, 11 watts. Yes. And so then the actual peak power is going to be worse. Because I need like a square root of 2 factor there. Because this is RMS. And so the power factor for RMS to like for how was that? RMS, I think it's a square root of 2, but then it's actually going to be 2 or something. Yeah, the RMS voltage is the peak divided by the square root of 2. But in this case, we are actually getting the peak. So it's multiplied by the square root of 2. But then the current also, yes, it's multiplied by 2. Peak power is that times 2. So that's the peak power there now is the I won the loudness war, peak power. And then min gain is wrong there. Max power minus peak power log 10. Wait, max power divided by peak power, right? Okay, that's more like it. And 12 dB should be twice the... Like okay. Yeah, that's because of the timeouts. So that's expected. So basically the main gain is minus 12 dB, which is 4 times the voltage is 16 times the lower power. And that just about adds up. So yeah. I think the math is right there. And so I want some debug prints here. Yeah, I do have the debug print there. So I guess I just run this and probably run it after some app runs. It's also getting late, so I probably should check out. But let's see if it actually works. So let's go SSH speaker test.
Front, left.
Okay.
Front, left. Front, center.
I think
front,
that's not working.
Right, rear, center, front, left.
Also, those are already pretty loud. I mean, hopefully I'm not destroying my speakers with simply that, but so iSense at least got turned on, so I think that's working. But I didn't get any data out, so something is wrong. Oh, wait. Didn't turn on verbose mode.
Front,
Ah.
front, center, front, right, rear, center, front, left, front, center, front.
Why is the coil going below the... Okay, no, the temperatures there are weird.
Rear, center.
Okay, that something's broken there. How do we end up with magnets below ambient? That doesn't make any sense. Wait, why is magnet 0 there? Is T-ambient not loaded? Oh, wait. Times T-coil.
Left, front, center, front,
Okay, that's still not quite right. I think those were the initial temperatures, and then why isn't it getting updated? I mean, the tower is large, but okay, let's initialize those to ambient. It's just being easier to see what's going on. Or is it that I am messing up the alphas or something? Oh, that should be right.
Front, left, front, center, front.
Why is it going down?
Right,
The power is
rear,
right, at least.
center,
You
front,
can see it.
left, front, center, front.
The power goes up. So that the power is fine. What's up with the magnet? The ambient plus PEEP TR magnet. Oh, wait. T coil target is ST magnet plus P times T coil. Okay. But then how did T magnet target end up confused?
Front, left, front.
How are we dropping the magnet temperature?
Front, left.
Is this a float precision thing?
Front, left.
No, it shouldn't be a float precision thing. We have more. We do, right? Yeah. And yet it looks like a float precision thing. Because because 1 minus that is going to be very small. I think I need F64 for those. Yeah, let's keep the actual temperatures as F64s.
Front, left, front, center.
Okay, now
front,
it's right.
right,
Stop printing that.
front, front, left, front, center, front, right, rear, center, front, left, front, center, front, right, rear, center, front, left, front, center, front, right, rear, center, front, left.
Yeah, and the power in the tweeters is much lower because they have the high pass filter on them.
Rear, center, front, left, front.
Okay, and that looks pretty reasonable.
Front, right,
This didn't work, right? No. But I have the test tone stuff I can try. Git else something. Like audio user utils scripts. So I can probably have an option on test tone to not capture. Make audio utils scripts test tone. Oh, I don't even have options here. And so let's do channel 0, which is one of the woofers. And I did minus 6 dB and then destroy it. So let's do that again, and then we can see if we get roughly the same numbers as before. Which means I should use the IPython thing again. Oh. Oh, that's just Rust. Asahi git Asahi mnt mastery Asahi git speaker safetyd and Jupyter notebook. I'm in the wrong directory for that. That's where I want to be. Scripts, temperature model, IPyNB. So let's grab the C0 minus 6dB, which I think was pretty nasty. And in this case, the just click run on everything. Oh, and this is the wrong model. That's for woofer. So I want the tweeter model here. Index 4 is out of bounds for access too. And I want a bit more of moving average window. So then, because we're assuming ambient is 50 in this case, I'll do that. And that means that after 200 seconds of that, we should be expecting a modeled temperature of 85-ish. Assuming we start at 50. Yeah, okay, that's, I think, doing the right thing. Interesting. Wait, 112 degrees? That would explain the reduced power. But that doesn't match this model. So either, I mean, still it should be 70. Power 2 watts. And it does have a, oh, wait, no. So it is reducing gain at that point, which is good for the test, but that is claiming we went way faster than we should have, way higher than we should have, which means something. Oh, wait. Because I was controlling this with the speaker controls. I'm pretty sure that I'm getting that reset, of course. Yeah, minus 550. So then if I set amplitude to that, should be equivalent without messing with the speaker volume. Also, it's interesting. There's left speaker. All right, so all the woofers got okay. So the grouping works. Okay, yeah, that's more like it. 90, 100. Okay, starts reducing there. Oh, interesting. Must be when the gain hit a reduction point there. Still, that temperature model doesn't add up with this one. Because I'm not expecting it to go to 100 that quickly. The power is very unstable. That doesn't look right. So the power I got here was 0.7. Okay, yeah, here we are way over that. And I think that's wrong because it should be totally consistent. This is a sine wave. So power, something's wrong with the power. Oh, is it because, wait, how was I calculating the scales here? Yeah, it's supposed to be like 375 and 14. It could be that I'm just seeing the wave here. Maybe the buffer size is too small. Yeah, because 120 is, yeah, okay, it's just, okay. So now we just have a much larger power than expected. Does that power add up though? We're doing minus 6 dB below the max. What was the max power we got from the thing? 1.28 watts, peak power 22 watts, and we're at. No, that doesn't look right for peak power. The amplitude is minus 6 dB, so it should be about 0.5. Yeah. Which means it should be about a quarter of the power. So 5 watts, but we're not seeing that. But then the Python was calculating way less than that, so wait a second. Oh, wait, did I think I forgot to divide, or I'm not dividing by the peak power 22 watts? No, that doesn't make sense. I think that's wrong. No, peak power is fine. I think it's something wrong with the... No, but the voltage and the current should be scaled fine. Okay, at 15.5 dB volts, the voltage should be that, and then it's divided by 2 because we are lowering 6 dB. The voltage should be 3 volts. RMS. Something's not adding up. Oh, wait, this is one of the weird modulated ones. I think I just screwed up the files. Oh, sine is... Okay, sine is modulated. Okay, fine. That means modulated sine. Okay, that's more like it. And that means peak is like 4 volts, and that's like 3... Okay. So now, offset, colon, and actually do the whole thing. 1.77 power. Okay, that makes more sense. And then we hit 100 almost immediately. Okay. That is making a lot more sense. And the power at the end is going to be lower because the temperature is higher. But then I should plot the power. I do plot the power. And that's this one, I guess. So the power starts a bit at around 2 watts and then goes lower. If I don't plot the I and the V, yeah. So the power should be a little under 2 watts. And what the Python is saying, I think it's also just the averaging now. So if I make the buffer size even larger, I don't know if that's going to work, but it says 2 watts. And the reduction is working. I would say it's working. Whoa. The sound really changed there for some reason. I don't know why that happens. I guess it's just the way it reacts to, like, the rattling is different, but I guess it's just the mechanics of it make it sound interestingly weird in different ways depending on how much you overdrive it. But now the temperature here isn't. Wait, that's also wrong though. Why is the model so different from the actual temperature on this one? Oh, because the coefficient something. No. Now I have now I have a factor somewhere that I shouldn't. This used to match. What other files did I have? I had minus 16 dB. Oh no, this is because I think we decided that at this level, because of the rattling, we decided that it wasn't accurate, and that's why I had the sine thing going on. So it overestimates because of the over excursion. I think actually limits. I don't know. There's probably like impedance effect or something, or just the temperature measurement was off. Yeah, I think that's what it was. But yeah, no, the actual model works for like minus 16 dB. And then, so we have T magnet target at 37. Right, so if I set the starting temperature to 50, which is the same, the Tmac target should be 57.44. And that should be the thing it trends towards. So if I do the minus 16 dB test, you should expect the model to do something similar to that. So it's quickly 55, yeah. 56. Yeah, that looks about right. So if we are doing all the math right, the final numbers that we end up here should equal the final numbers that we end up here after 200 seconds ish. So I guess the next question is, do I feed I want the loudness war at full? Well, the kernel is now at minus 3 dB versus macOS, so I could do worse. But the question now is, do I just feed I want the loudness war on full throttle to all the speakers? At least the tweeters have an HPF, so there's that. And see if I blow anything up or not. Thing is, I think if I do that, I'm gonna like break them from over excursion before I break them from the temperature. At least the woofers. And like that's not something the safety daemon is gonna protect against. That's just the EQ is sort of gonna take care of that. But the idea is that if you're making that much noise and it sounds that bad, the user probably should stop whatever playback before they damage their speakers. And that should only happen if you're not using the decent processing we're going to be having. But the temperature thing is a lot more critical in that it will blow your tweeters out very quickly. PowerPoint 21, that's exactly what we see here, so that's all good. So by the way, we actually do want this buffer size to be pretty large, because it's okay to have like a 1/10 of a second latency for for the safety stuff. Actually, might make it a little slow, but basically, you don't want this to be too small because it will also affect CPU usage. And since this is global for anything that's happening with the speakers, you don't want this to be too small because it'll just kill efficiency for like regular audio playback, like high latency audio playback. So 4096 might actually be a good number for this. And we probably actually want to make that a global action. So let's do that while that is running. Period. Main rs. Okay. We ended up at magnet 54, coil 60. That's what it should be. So the model is doing the same thing. So it'd be nice to have some good solution for the default temperatures that is actually safe. And that needs to be F64. And period. Yeah, so that starts at this volume. It starts limited a little bit and then quickly drops. If I go for the 6 dB thing, it's going to be, let's see, at 6 dB how long it takes to sort of go down. Yeah, so it starts at minus, then lowers. It pretty quickly settles anyway. So the next thing we need to do is to implement the like catch up stuff. But it's getting kind of late. It's midnight, and it looks like this works. So what should I do? Should I torture it with? Actually, let's try something else first. Let's try. The like full throttle speaker test, which at least isn't is that really only 0.15 watts? I guess. Okay, so that isn't actually using full power then. Because otherwise it'd be louder than that. I guess there's no volume control for this. Okay, so let me just use an actual like sine test to get an idea of how loud this thing is at that amplitude. Let's do like 800 hertz. That's gonna be. Okay, that's pretty loud. And that's at -6. Now I assume that is not going to. Yeah, I don't know about the excursion issues with that kind of volume level. Because I think that's... It did sound like it was rattling a bit. Let's try something lower, like 300 hertz. Okay, that's already kind of rattling. But I think that's sort of expected. Let's try another one of the speakers and see if I didn't destroy it. That is actually rattling a bit. I'm not sure if that's normal. So 2, 3, 4, 5 should be the other ones. And that's also rattling, and I don't think I've ever messed with that one. So I think they're just like that. Yeah, I think they just rattle a little bit. But yeah, 6 dB is pretty noisy on these. But it, the Daemon is actually limiting it to like -3 dB at that point because of the high magnet temperature assumption. Okay, so we still have a bunch of stuff to do that needs the. We need to figure out how to make it catch up when there's no samples coming in. But then again, we might just be able to also use that to estimate the sample rate. And then it's going to need all the safeties and everything else. But it looks like the basic idea works. So I guess I probably should clone the repo and... And in principle, this is enough to, do some stress testing with, hopefully with the EQ stuff on top, though. I'm not sure I would... Well, I guess I should. I should do a stress test without that. I'm just kind of scared of the, mechanical damage that can cause that this is not going to prevent, but maybe it's okay. What do you think? Should I try giving it the I won the Lapness Award treatment? I have that. I think I have that somewhere. Yeah, in there. Test data, yeah. This is going to go well. Why is the CP not working? Oh, this is .lan. So Mac audio utils. What, HomeLina? Yeah, was that like Ardour? Yeah, it's like I have the like audio like the audio production setup on this machine, and she was using it at one point. So where is I'm doing? So how do I want to play that back? I think FF play with some kind of channel up mixing thing. Do I want to just play it on all the speakers at once and watch it? Or maybe just play it on the woofers first. Let's just do a normal playback first, which means it goes on the woofers. FF play. I won the loudness war, and how do I set the speaker output? Play Elsa. Actually, I think you use FFmpeg for that. That didn't work. Oh, on 0, 1. Right. And I need to resample that probably. Let's just plug. No. Let's PCM1P. Mpeg channel map. How does that work again? There's that. I think pan is what I want. C0 equals C0, and so give it to the front left and front right speakers. Let's do a low volume first to make sure that okay, yeah, that sounds about right. I think the resample. I think that's something wrong there. Yeah, there's an issue with the rate. Where's the sample? A resample. Yeah. Yeah, that's the right sound. Okay, and that's at volume 0.1. It's already loud as hell. Like that's the volume I would expect, and that's 1/10 the voltage, so 1/100th the power. At least we got the right speakers, left woofer and right woofer. Yeah, so this isn't going to destroy anything, obviously. 0.5. Ooh, that's nasty. But it quickly reduced the gain. I'm scared of the mechanical problems with this. Ow, that's loud. It's already loud. It's at half volume. And the kernel is 3 dB lower than the macOS Max. And this is at 0.5. It's not playing faster than real time. It should be real time. And it's real time. I can hear that it's the right... Oh, you mean the speed here? That's because of the buffer. The buffer's a bit more, so the average speed starts off higher. Ow. It is fucking loud. It seems to be working though. It's actually limiting the power here at -4 dB, which means that in principle I can just set it to full power and it's gonna just limit it more, and it should sound exactly the same eventually. It's just gonna be really loud briefly. Ow! But it quickly lowered the gain. So it is gonna be a bit louder because the coil is actually getting hotter, so it's getting more power. Ow! Ouch. Ow. And as the magnet gets hotter, it should be eventually decreasing the gain even more. Let's see if we can get it to click the gains a bit lower. It's gonna take a while to heat up more. You point the microphone that way, you get the full experience. It is fucking loud. And it's a laptop. Like, this is unreasonably loud, and it's limiting it at -9 dB right now. Why not make a laptop with such capabilities? Yeah, this is why we're doing this, right? Because these laptops can actually sound loud and like sound nice with the right EQ and everything, and not destroy themselves if you have the safety model. This macros even get this loud. It gets pretty loud. I don't think quite this loud though. But again, the user space EQ model is going to limit loudness in other ways. This is just raw, like, bumping craziness into the speakers. And also this song is like the loudest song in the world. And like, it's only 1.2 watts into the speakers. It's not even like, you know, that's the power of 2 watts and a half of sound. Well, not even that because it's not that efficient. Okay, so that was the whole thing. I wonder if we destroyed anything. Let me run the test tone again. Mac audio user util scripts. That sounds kind of the same as before. Ooh, that rattling. Okay, that's... What's the... -6? I'm not sure if that's supposed to happen. That one sounds fine, though. Oh, wait, that's woofer 2. I haven't touched that one. That's one of the ones I made suffer. Okay, that's pretty nasty, but I think... Okay, let's try 12. Still kind of rattly. But... let's try channel 1. How is this rattly? Channel 4? Yeah, it's also kind of rattly. Yeah, it sounds exactly the same as channel 4, so... I don't think I've destroyed anything. Let's attempt to get it right. 140 degrees is the max. I'm pretty sure I got the tweeters on the M2 Air up to 300 degrees when I blew them up. So, but yeah, no, I think this survived the test. So are we going to do the tweeters now? Let's do only the tweeters. And let's try 0.1 first. Is that the tweeters? No, it's the woofers. I think there's a channel ordering thing happening here. Oh, that's the tweeters. Okay, but it's actually very little power because of the high-pass filter. We could remove that, but I don't think I want to do that. That means, though, that the worst case for the tweeters is actually probably not this song because of the filter. Ow. But, okay, so that's, yes. Screw it. Ouch! 1 watt into the tweeters. So even with the high-pass filter... Ow! It's already limiting them. Holy crap, that's shrill. And now it actually got better. Yeah, and you can hear the shrill is much higher because there's a lot more low end in this part of the song. So the tweeters actually recovered a bit. So we still have to add the attack release times to the game. Right now it doesn't really have that. It only has hysteresis on temperature, so it reacts a bit too quickly. That's pretty good though. It's not at 2x speed, maybe. Maybe. Ouch. Okay, I'm gonna do it on all the speakers. And I might want to walk out of the room at this point. Ouch. Why is the woofer... Oh, wait, I think I have the... Why are some of the woofers getting less power, even though they... That's weird. The woofer 2s have like half the power of the woofer 1s. Is that because they're different speakers? Let me just try with the test tone first. So that should be channel 0. So 0.17 watts on woofer 1. And woofer 2 should be channel 4. On 0.17. Okay, so why... Why was the power so different? Did I screw something up here? That doesn't sound right. Unless it's like because of them firing at the same time, it causes a difference in power consumption. What if I lower the volume? 0.1. Yeah, it's like twice. I don't get it. Because the test tones do get me like 0.17 on that one. And, you know, the same on that one, so I'm kind of confused there. That's weird. Is it FFmpeg doing something dumb? Let me try just 2 speakers. It's 0.15 watts on woofers 1 and 2. And 2 and 3. Okay, that's... It's 0.15 watts, 0.13 or something. Why is woofer 2 quieter now? Oh, is it one of those things? I think there was a bug somewhere where, like, if you didn't touch those controls... No, but it's... Is it just FFmpeg being weird? Like something with the subwoofer or something like that? I think it's FFmpeg doing something weird with, like, thinking one of those speakers is the subwoofer or something. Wait, now it's 0.15 watts. Hold on, what? Is it about having them at the same time? But they're on opposite sides. It shouldn't make a difference. Oh, but even if I have, like, nothing in C2, it kills C3. Okay, now something's weird here. I don't understand. Is this just FFmpeg doing something really weird, or is there like an effect to having data on more than one channel? Okay, let's generate data on more channels. Yeah, it's not FFmpeg. Okay, now I really want to know what is coming from VI-sense here and why. Maybe there's a bug in the VI-sense code and somehow... Let's only do 2 seconds, don't need much more here. And that should be this one, 16 dB double. So we get channel 4. And it's actually plot V and I. Oh, just look at the power. The power was 0.16 on this one. And 5. Yep, it's 0.8. Oh, that... Now we have a problem. And this is one for Povik. We are losing data. Ha! Okay. Interesting. Yeah, so that one looks fine. But we get a choppy mess on one of the channels. Okay, I gotta ping Povik about this one. Because obviously that's going to affect the temperature sensing and give us bad data and bad protection. So I bet it's some kind of bus conflict thing. What hardware model am I trying? This is the 14-inch MacBook Pro M1. And is that I or V that we have an issue here with? I is the problem. V is fine. Uh, Apple. What is this? Stocks. So in this case, I'm just doing left and right. And for like the second woofers and stuff, add amplifiers. D to R left. So they're all on the same bus. Yeah, so they're just there. And I know there was a thing in the device tree about ORing like there was a wired OR, and there was a thing here to clear them. E6000 J31. I think it's in the common file. So I'm kind of curious about the current. Huh. Okay, I think I have an idea of what might be going on. So, okay, so it's like small numbers. So that kind of looks like bus contention. Um, or possibly another chip on the other bus is putting stuff on there when it shouldn't. Yeah, because if the left side is putting data on there when it shouldn't, then you would get something like that. Because they get ORed internally. It's in sound, sock, codecs, TDA, TAS 2764. I think I see the problem. That should be 8. Yeah, I think that's the problem here. Oh, it's actually built. Because I was counting in terms of 16-bit slots, but the actual bit width of a slot is 8 bits. And the slots here are counted in terms of 8-bit slots. So that's, I think, just a typo in that part of the driver. And so it makes sense that it gets truncated and only some of the slots don't get zeroed out. And then because of the wired order, you get garbage on the bus and it breaks some of the samples. You probably get the last bit transmitted, which means it's the top bit from, the top bit from the previous slot, which means that, that explains that. It all makes perfect sense. Wait, reboot. Oh, that's not working. Well, okay. So I should get the print case on that. Actually, I did something to grep for. Print kx percent. I did with it right. I can't find the print. Okay, I'm gonna go to the toilet. Be right back. Back. Well, it should work. Why is it not printing that? Oh, is it only when you open the device? It might just be when you open the device. Nope. What? I'm confused. I don't get it. Is it just because it's a raw print key? I don't even know how this stuff works anymore. Maybe it ends up in debug mode, and if it's not a debug, if I don't start it in debug mode, those get eaten. I think that might be what happened. I don't know how to Linux. Okay. But I think I know what I'm going to see. I'm going to see that mask cropped because it is calculating the mask wrong. No, why? I'm confused. Why? Oh, wait. I'm not compiling the right kernel. Oh, because I think I turned on the EFI loader for some reason, and that's not a zipped image now. Right. Okay, that makes sense. Why does that change the Rust bindings? Oh, I guess because all the configs get parsed. Okay. Still no, but okay, there we go. Yes, that's the problem. Which means I just undo all this crap. Put an 8 in there, and we fix the problem. So get in there. Make sure it's in that Topovic. Okay, we should be good now. Now they have the same power. Okay, now let's run all of them. And now we get the real test. All the speakers 0, 1, 2, 3, 4, 5, 6 channels, volume, blow it up. Ouch! But yeah, the powers look about right there. I think my neighbors might hate me. It's 1 a.m. It's a good thing the walls are good here. Okay, my ears actually hurt now. Look at the tweeters get throttled in that part of the song. that sounds like it survived. I don't hear any blown speakers. Let's do a speaker test.
Front, left, front, center, front, right, rear, center, front, left, front, center, front, right.
Well, we didn't melt any coils.
Rear, center, front, left, front, center, front, right.
I have my doubts about the rattling issues, but I think these are supposed to be pretty
Rear,
rattly to begin
center,
with. So
front, left, front, center, front, right. Rear, center, front, left, front,
okay, well,
center, front,
I think that's that. I'll have to test this with like the proper
rear,
speaker EQ and all that, and
front,
see what
left,
power numbers we run into, and
center,
also
front,
whether we want to remove the 3 dB
rear,
extra safety
center,
margin that's in the
front,
kernel right now.
left, front,
And then, of course, there's the
center,
whole
front,
interlocks and
right,
safety and all that we
rear,
need to add, and
right,
also the catch-up feature and like sample rate
rear,
detection, and
center,
all the other
front,
stuff. But
left,
but the basic model works.
center, front, right,
So there's that. Okay, it's 1 a.m. I should
rear,
get
center,
some
front,
form of
front, center,
dinner or
front,
something and get some sleep.
right,
So I will see you
rear,
all
center, front,
later.
left, front,
Not sure when I'm
center,
gonna finally
front,
wrap this up
right,
because I also need to really get the bring up on the M2
rear,
Max
center, front,
Pro stuff
left, front,
started, and thinking I'm doing that
center,
next week.
front,
So
right,
might do that and then go back to
rear,
speakers week
center,
after or something like
front,
that. We'll see.
left, front, center, front,
But yeah,
right,
that's it works. Yeah. It
rear,
does what it's supposed to
center,
do.
front, left,
So
front,
then we just make it
center,
safe after
front,
this.
right,
But it survived the one the loudness ward test,
rear,
so
center, front,
there's that.
left, front, center, front, right.
Alright, catch you next time.